Okay, what is it? Master boot record. It is when you are using a BIOS, or if you are make a disk as a what type of disk, like you are added disk, it will ask what type of disk you want it. So if you select a master boot record type, the disk type is master boot record. It is the thing. Okay, not like a physical connection. It is a type of disk type. Okay, master boot record. So in a master boot record, we can create four primary partitions. Remember, you can create a four primary partitions. Once you complete a four primary, if any disk space is left out, you cannot create a another partition. Okay, otherwise you can go through three primary and one extension ex and one extended partition. In extended, we can create a logical partitions. You can create a logical partitions. Okay, four primary partitions, or we can create a three primary, one extended partition. In one extended, we can create a multiple logical partitions. We can able to create it. Okay, that is a rule. Next, each partition size support 2 terabytes of size. Size support up to 2 terabytes. It's up to 2 terabyte of disk partition size. Next type of the disk is GPT. GU, GUID, GUID. I have what I'm getting. GUID partition table. Okay, GID partition table. So what is a GID partition table? It is a type of partition like MBR only. Okay. It support 128. So primary partitions. Primary partitions. So support disk less than 2 terabytes. Um, so support disk support up to 2 terabytes. This is a so more than 2 terabytes it support. Support more than 2 terabytes it support, and in some textbook it is showing it support up to 18 EB. Okay, up to 18 EB. Some textbook showing a 9.2 zettabytes. Okay, some textbook showing a 9.2 in an internet is mainly zettabytes. Okay, so you can try anything, no problem. Okay, so it's more than 2 terabytes because we don't see any zettabyte or things. Terabytes disk we seen. So if you take 4 terabytes, you can verify it. Okay, and important, like if you are in a BIOS, if you are using a BIOS firmware, firmware or firmware, anything you can put it. If you are using by default MBR disk, okay, by default the first disk is by default it is a MBR disk. Okay, by default, like you have a empty disk and you connect the empty disk and no operating system, when your operating system automatically convert into MBR. So this is UEFI. If you are using this firmware, by default it's a GPT disk. It's a GPT disk by default, and of course the supporting operating systems also differ. Like you have to use Windows 7, Windows 8, Windows 10, sorry, Windows 8 and Windows 10 by UEFI supporting operating systems, and CentOS 7, Enterprise Linux 7 onwards, it support. Tell you about the OS kind of stuff. This is a major MBR and GPTs. Next, come to file system. There are multiple type of file systems are there. Generally, FAT in a Windows we are using, right? So FAT file system, ntfs file system is a general file systems are there. So FAT file allocation table. So better I will check the spelling. Today something is happened to me. FAT means it is showing that file. Okay, so yeah, that's the thing. Allocation table, ntfs. NT means new technology, always new technology file system. So both are file systems only, new technology file system. Generally FAT32 both are there. So I'm telling you about FAT32. FAT32 support up to the drive space. Means in the single disk space up to 32 GB only. FAT support up to 4 GB only. If you take FAT12 is there. Okay, the FAT only FAT name is a FAT. Okay, up to 4 GB only, maximum 4 GB, not more than 4 GB. NTFS support up to 2 terabytes in a XP time, but it support more than 2 terabytes also. Okay, so these are the general system, and NTFS have a 5 qualities. NTFS advantages also there, right? So what are there? Quota, quota disk quota, okay, NTFS support, disk quota, compression, encryption. You remember or forget?
Security.
Yes. Security. Security is a very important one. Indexing. Indexing. These are the 5 qualities of NTFS. So out of that one, security is a very important one because FAT don't give security. NTFS security means file access permission. Quota means limitation of access a disk. Okay, compression, compress the data. Encrypting the data using EFS file system. Okay, these are the file systems existed, and of course there are more file systems also there. So that's why I put a very small one. Okay, FAT has a limitations, but most of the flash drives use FAT systems only, like your mobile memory card flash drives, like memory cards. Okay, memory cards like SD cards are there, no? Memory cards use a FAT file system, but nowadays we have a more than 32 GB, more than 32 GB memory cards also available, right? And files size also big nowadays. So for that one, it is introduced with a exfat. Okay, exfat is introduced, so it support more than 32 GB, and big files also we can able to store in a exfat. One more file system is introduced, better. Next time you see, you don't get confused. Okay. Ex file system more than support 32 GB, and big files also supports. File size also big. Okay, so big size files. So I'll put a big file size. Next, REFS. What is REFS? Resilient file system. Resilient file system. Here it is came. Resilient file system. Microsoft introduced this resilient file system. What is REFS? Resilient file system. Okay. Resilient file system don't have ntfs properties, but it support resiliency. It means it supports crc. So whenever you put a data in the resilient file system, automatically the system calculate and generate a crc value. What is crc? Anybody remember crc?
Cyclic redundancy check.
Cyclic redundancy check.
Yes, very good. Cyclic redundancy check. It is nothing but an algorithm. Okay, it's nothing but an algorithm to produce a sample data from existing data only. Okay, so what is that sample data? So that sample data, using that sample data, we can calculate our actual data. So this data is there, our data is corrupted. You know, sometimes earlier days people are sharing this ppt, like people copy a ppt in a pen drive, they're connected to their pc and open. What happened, the paper is showing it is corrupted. Okay, it's showing it is corrupted. Why it is corrupted? Because while transferring the data, while storing the data, when accessing the data may corrupt it. So resilient file system make sure that data should not corrupt it. So to make the data as non-corrupted, so it will generate a crc value and it will keep it. If you want to see, try to check winrar files. Check the winrar, any dot with rar files are there, no? That rar files, it is a compression archiving thing, right? So it is archive the data. So when it is archiving and compress and archive, both it will do. So you can see a crc value inside of that one. So whenever you extract it, so you will get a data safely. But sometimes the rar file also will be corrupted, then you can repair it by using a winrar application also. Okay, so that is a possibility, like it won't let your data is corrupted. Okay, so that is a crc value. Of course, you can put a big files, but it won't have a properties like a ntfs. Security kind of stuff won't work. So this is about a refs, mbr gpt. So basic disk and dynamic disk is also there, so I will tell. Fat ntfs, refs. If you convert from ntfs to refs, we can convert it back also. Lot of data is there. Mm, Basic disk and dynamic disk. Normally, any disk is a basic disk only. In a basic disk, we can create a partitions. We can install operating system also. We can put OS in a basic disk, and we can create a partitions. We can divide a disk into multiple parts. What is a partitioning means? Divide disk into multiple parts or partitions. So that is a basic disk. So usually we install a operating system. We put operating system into basic disk only. Dynamic disk, operating system we can't put it into the dynamic disk. Okay. Okay. can't install OS in dynamic disk. Okay, and dynamic disk. Next, so dynamic disk we can make a partitions. We can create a partitions in partitions. We can create a partitions in dynamic disk. Okay, we can create a partitions in a disk, but disk purpose is not for creating a partitions. So for creating volumes. Okay, to its actual purpose is creating volumes means adding multiple disks into single volume because that we can't say a partition because the partition only C drive D drive is there, but we call that one as a volume. So partitioning, we can do the partitioning in a dynamic disk, but the main aim of dynamic disk is we can combine the multiple disk into single volume. Actually we should say combining, so combine or adding anything. Okay, combine, combination, combine, say anything you understand that is okay. If you don't understand then or adding, combine or adding, what is the volumes, so like that. So different type of volumes are there in the dynamic disk, of course. Different type of volumes we can able to create it. Okay, different type of volumes we can able to create it. Simple volume, spanned volume. Okay, stripped volume, mirror. Okay, these are the main volumes directly we can able to create. One more volume is there, that is called RAID 5. That is only one in a server. Okay, so RAID 5. Okay, these are the volumes we can able to create. Okay, we can using a dynamic disk. Where are we now? So VHD, VHDX I will tell in a storage. Okay, these are the volumes you can able to create: simple volume, spanned volume, stripped volume, mirrored volume, and RAID 5. Mirrored is there. Okay. Then what is this RAID 5? What is this RAID? What is a RAID? Anybody having a idea? RAID, redundant array of independent disk or inexpansive disk. Redundant array of independent disk or inexpansive disk. What is RAID? Redundant array of independent disk and inexpansive disk. What is a redundancy? What is a redundancy? Like we said resiliency, right? So like the redundancy means if I lost something, no problem, I have a backup. I have something like, okay, for example, um, you want to go outside and you feel like a bike punctured, no problem, you have a car, then you will take a car. So I have another choice, I have another backup. Or maybe you have a car and while you are driving, so the car got punctured, then what you will do, you have a Stephanie backside, one more tire is there, so we'll replace the tire. Immediately you can solve the problem, right? That is a redundancy means I have a backup plan type. Okay, you have another plan. If something is failure, no problem, you can do with another thing. Sometimes I cook. Okay, so sometimes I do experiment. Okay, if it is fail, something goes wrong, it's fail, so I need a backup plan, so I should have some other arrangement for food and do it. So if you want to do some experiment, then do it before you are having a lunch time. Okay, so for example, you done at 7 o'clock, if something goes wrong, so 8 o'clock go outside and eat. Okay, so this is like a redundancy. Redundancy means have some other plan. If you something is failure, no problem, you can get it. So this is a ride. Here, generally there is a ride levels are there, but in a before going to ride levels, I want to tell two type of rides are there. One is hardware ride, and another one is software ride. Hardware ride means there is a hardware part called a ride controller is there. Okay, so hardware part called a ride controller, and we whenever you connect a disk to the ride controller, and uh, we can con- we can configure the ride levels on using a ride controller options. Okay, and of course SCSI drives also support ride controllers. Okay, so on the SCSI board itself contains a ride related thing, so like which disk should be in a same ride. Software ride, like you don't have a hardware ride or maybe a small organization, so you cannot offer a ride controller or SCSI kind of stuff. Still, you need ride related thing. So you can use a software as a ride. Like we can take a software and we can make a ride labels. Or if you are using a server or a Windows operating system, no problem. So you can normal Windows operating system support at least 2 3 RAID level up to here. Windows 10, Windows 8, Windows 7 support. RAID 5 won't supported by desktop operating system. RAID 5 won't support by desktop operating system. RAID 5 support by server operating system only. So what we need, so we need application. Either you have a RAID application, something application to perform the RAID kind of stuff, or maybe or you need a server operating system. Using server operating system also you can create a RAID, and the levels are there. RAID levels. Okay, so RAID 1, sorry, first is RAID 0, then RAID 1, RAID 2, and RAID 5. That's it actually, and I'm going to RAID 6 also. I will give you a small information. RAID 0 is nothing but your stripped volume. It is nothing but a stripped volume. RAID 1 is nothing but a mirror. RAID 2, sorry, RAID 2 is not there, no? RAID 0, RAID 1, RAID 5. Volume, mirror volume. RAID 5 is a RAID 5, RAID 6 RAID 6 only. So we'll see one by one RAID volumes here. So better we can remove this one. So RAID 5, RAID 1. So no RAID 2. That's it, right? Correct one. RAID 0. First is a RAID 0. It is called as a stripped volume. Okay. It is called as a stripped volume. Not double P, single P only. So stripped volume. So we need a at least a minimum two disk. Required a two disk minimum. Minimum two disk be required to perform a stripped volume. Okay. Combine the two disks. It's combine two disks as single volume. Combine the disk. Combine the disk as a single volume. If you take a two disk, then combine the two disk. Okay. So we'll see in a diagrammatically how it is look like. Okay. This is a disk, and this is a disk. Two disks are there. think like this is a 1 terabyte of disk. This is a 1 TB. Think like it is a 1 TB, and this is also 1 TB. The two disks are there. Now I combine these two disks. I combine these two disks. What is the result? 2 terabytes. What is the result? 2 terabytes. What is the result? 2 terabyte. This is called a stripped volume. Write 0. Stripped volume. Okay, this is a stripped volume. I'm combining 1 terabyte, 1 terabyte. Combinedly, I'm giving 2 terabyte. It means, for example, this is a E drive, and automatically this disk also become E drive, and total E drive space is 2 terabytes now. Okay, so the second one automatically become E drive. Okay, this is one E drive, and this another E drive. Combinedly 2 terabytes. This is not another E drive. This is a nothing. So when I add this one, so totally become E drive is 2 terabytes. Next, write one is called a mirror volume. Mirrored or mirror, whatever it is. I took a disk, and I took a disk 1 TB. I took a 1 terabyte, 1 terabyte. This is for example E drive. Of course, this is also now everything is become one E drive only. Okay. The size of E drive, now is nothing but a 1 terabyte only. We are combining a two disk. We are combining a two disk into single volume. Combining a two disk into single volume, but resultant is 1 terabyte only. So what is the difference between this and this? By I'm getting 2 terabyte, 1 terabyte. Here is I store a data. I store a data. The data can be stored here or can be stored here. So combinedly, I'm getting 2 terabyte of space. I put a data into E drive. The data can be in a first drive or second one. This is a disk 0, disk 1. For example, it can be stored here or it can be stored here. But I'm getting high size. For example, I have got a project. I have to put a lot of data. Single disk is not enough. I put another disk and I created a strip. I added another disk. I created a strip. So what happened? So they both combined and it is giving a more space. That is a stripped volume. Okay. Now, what is the disadvantage of this stripped volume is if one of the disk is failure, total failure. One of the disk is failure and total data loss. You can't access the lost data. You can't access the lost data. Understand? If one of the disk is failure, so you cannot access the data. That is a in a stripped volume. So we will get a maximum size, but if one of the disk is failure, total data loss. Mirror. Mirror is generally what we are using. What are the data stored in one disk? Same data will be stored in another disk. What are the data stored in a disk? Same data stores in another disk. Advantage of this disk is if one disk is failure, if one of the disk is failure, still you can able to access the data. Understand? If one of the disk is failure, still we can able to access the data. That's why this is called a single disk failure. Single disk failure. Okay. Next. But there is some disadvantages also there. What is the disadvantages? If one disk is failure, still we can able to access the data, but but whenever one disk is failure, right, so you insert a new disk, you put a new disk in that place, what happened? The mirror will be broke. The mirror is getting broke. So that is a disadvantage of mirror. If mirror automatically won't configure, again you have to configure the mirror from starting. You have to take completely data backup and create a mirror and you have to restore it. So mirror won't attach directly. So that is a problem with the mirror. Next one is a write file. But next one is a write file. Write file name is write file only. Here we take three disk. Understand, this is a three disk. Okay, this is a 3 disk. So each one is a 1 terabyte of space. For example, just for example, I'm taking. You can take 2 terabytes, 500 MB, also no problem. Okay, 1 GB, 2 GB, anything, no problem. Same space required. That's it. This is a one disk, another disk, another disk. I combine all the disks. I combine all the disks, and I will get 2 terabyte of space only. I combine three, each one is a 1 terabyte, and I'm getting 2 terabyte of space only. Each one is 1 terabyte. Combined, I'm getting 2 terabyte. What happened to one more terabyte? You won't get that one. You'll get a 2 by 3 of disk space. You'll get a 2 by 3 size of disk space only. We'll get a total disk size only. We'll get 2 by third of a total disk size only we are getting here. But here, if you compare with this one, 50% means half of the disk space is gone. Half of the disk space is gone. You take 2 terabyte, 2 terabyte, you will get 2 terabyte on. 4 terabyte, 4 terabyte, you will get 4 terabyte on. But here, for example, 2 terabyte, 2 terabyte, 2 terabyte, you will get 4 terabyte. 3 terabyte, 3 terabyte, 3 terabyte, you will get a 6 terabyte. You will get 4 terabyte, 4 terabyte, 4 terabyte, you will get 8 terabyte. Okay, so 2 by third disk means 3 disk, 2 disk space you are getting. And here advantage is if any of the disk failure means one of the disk is failure, still you can able to access the data. If one single disk is failure out of 3, one disk is failure, still you can able to access the data. Okay, next point is what is the advantage over a mirror? So one advantage is 2 by third of a total space we can use it. Okay, um, another advantage is if disk is failure we are getting a space, right? Same data, no problem. If you remove the disk and insert the new disk, or maybe you repair the old disk, okay, automatically RAID will get online. Automatically RAID will get on. You need to configure from starting. Automatically RAID will sync the data and it will recreate the data on the new one. How it is possible? Because of parity bits. Because of parity. This is the parity. 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 What is this parity? The data in a one disk, for example, data name is A. That the A parity bits stores here and here. Means if a disk have a some data, for example, data name is B. Data name is B, and B's parity stores in another disk. So then, if any disk is failure, no problem. We can regenerate the data using parities. Okay, what are the disk? For example, this disk is failure. So A parity, B parity bits are lost, but this is B parity is there, here A parity is there. Using that, we can regenerate the data here. For example, your data C is there. Data parity is here. What will happen? If this disk is failure, C data is gone. But we can regenerate the C data using parity bits. This is called a single disk failure, single disk failure with parity. With parity. And I have written one more thing, that is write 6. Write 6 and write 5 same concept only. Only thing is number of disk using and number of disk failure is different. So here I am using 3 and also I am using 4 and I am using 5. So totally 5 disk we are using in a write 6. If 2 disk are failure, no problem. We will get a 3 by 5 of total size. For example, 1 terabyte, 1 terabyte, 1 terabyte, 1 terabyte, 1 terabyte. So totally 5 terabytes. Out of 5 terabyte, you will get a 3 terabyte of this. So it is a 2 disk failure candidate with parity. 2 disk failure with parity. Okay. So leave about write 6, write 5, write 6 same. Here is a single disk failure, here 2 disk failure, here 3 disk we are using, here 5 disk we are using. So we will get a 3 disk size, total size you will get a 3 disk size, 3 by 5 size we are getting, 2 disk failure with a parity. Okay, this is stripped, mirror, write 5, write 6. What about write 2, write 3, write 4, write 7, write 8, write 9? So there are there, but not popularly using. So write 0 is a stripped volume, minimum 2 disk we are using, combining disk as a single volume. Okay. Mm. So we'll get a total volume size. We'll get a total volume size we are getting if single disk fails. Total data loss. So we can't get the data again. Next, write 1 called as a mirror volume, mirror or mirrored, whatever it is. So here we are using a only 2 disk. We use only 2 disk. We cannot minimum disk. We are using 2 disk. So we combine disk, combine disk as a single volume. Okay. So total volume size is is equal to one disk is half of total volume only. Total size. Total size. Total size of the volume. We'll get a half size only. Half part only. So maybe understand, otherwise it will stay change the statement. Okay. I never use the notes also. This is the first time in your batch only. I'm typing so many things. If I don't use, I will explain it and leave it like very less writing part. 2 disks combining multiple disks like solve. Okay. If single disk failure is allowed. Okay, it is called a single disk failure without parity. No parity bits here. If one disk is failure, no problem. We can still access the data. If one disk is failure, okay. If one disk failure, still you can able to access data. Now write 5. Write 5 is write 5. We call this one as a, this is also single single disk failure. Single disk failure with parity. Parity bits are there. So using the parity bits, it regenerate the data. Okay. So total volume is accessible volume or total volume size. Accessible volume is a 2 by 3 of total size. Total size. Accessible volume is 2 by 3rd of a total volume after total size. Okay. And just for understanding all this, it's not point, not for a thing. Understand. If you understand, you will understand. That's it. Single disk failure. Total volume is like that. Combining disk as a single volume. That is a common one. Okay. Same thing as if one disk is failure. Okay, if one disk is failure, still we can able to access data. So that is one. And if disk replace, if disk replaced means failed disk replaced. Normally, failed disk replaced. What will happen? Data is regenerate in new disk. Okay? So that is a write 5. So of course I said write 6 is also there. Write 6 is no difference between write 5, same as a write 5, but it is a 2 disk failure with parity. And we forget to use version. Here we use a 3 disk. Use a 3 disk. Okay? And here is a, here we use 5 disk. So total volume size is 3 by 5 of total. Last year, last batch one, they people asked one question. So last time, we previously also they asked this question. Like student asked question. Sir, what is the difference and who will use this one? Who will use a mirror? Who will use 5? Who will use 6? So it depends upon your enterprise and requirement of redundancy level. Requirement of redundancy level and possibility of disk failures. Okay, possibility of disk failures depends upon your company and company cost, how much they want to put it on a risk, right? So it's a high risk is there, then we'll go with write 6, but it is cost, we have to use 5 disk, uh, little bit less disk risk, so then we'll go to write 5. And no, normally it's a possibility of data loss, like a disk failure is occur, like in our Vedic soft itself, lot of time disk failure is occur. We lost lot of data one day, like a student related information. That to latest information only. That not now. So it is happened 2 years back. The hard disk in the system failed, and the data in that one is gone. Luckily, Charan sir copied into some other place, so we didn't get a problem. Only the very recent 1 week data only there. So again they ask the people about the recent part, so they will arrange it, no problem. But if in case disk failure is common, so it possible, right? So we don't know the disk failure thing, it depends upon so many other things also there. Okay, but if it is a possible, like you have very important data in one disk, and if disk is failure, you have to keep data always daily, you have to take the data and keep it. But restoring the data take time, restoring the data will take time. So better to keep another disk and make it as a mirror. Simple office, small organization, one system, mirror is okay. But if you are going to enterprise, we need a faster solutions. So then we are using a 3 disk. If one disk is failure and replace the disk, and meantime the data will be transferred. So when you put a new disk, automatically data is regenerating. So that is the parity. So when you are in an enterprise, solution is write 5, write 6. If you are in a normal office, solution is write mirror. And you need a more size, then you will go for a write 0. Okay, as is a priority, you understand. If disk is failure and you replace it, regenerate the new data in that one. Okay, and another writes also there. Write 10, write 50 types also there. It is combination of. Oop, anybody came now? Okay, Aditya is disconnected. Okay, It's a combination of write 1 and write 0. So you will get both stripped and mirror. It's a combination of write 5 and write 0. Okay, so write 5 and write 5. Two write 5s are there. Think like one write 5, another write 5 combined together. That is write 50. Write 10. It's not write 10. It's not a level 10. It is a combination of 1 and 0. A set of mirror disk and another set of mirror disk combined, so it is become a ride 10. So this is the things about your ride. Okay, so what are the ride redundance array of independent disk or inexpensive disk? Okay, ride having a different levels are there. So ride 0 means stripped volume, combination of two or more disks become a single large volume, and total volume you are getting, total volume size you are getting here. And if one disk is lost, so total data loss. One disk is failure, any disk, if any disk fail, total data loss. If single disk failure means at minimum single disk failure, total data loss. Mirror disk, we are using two disks, okay, and we are combining a two disk into the single volume, so that is called a write itself. Okay, and we are getting off of the total size of the volume, means 1 terabyte, you got 1 terabyte only. Single disk failure without a priority, this is called a single disk failure without a priority. Where am I? Single disk failure with a parity. If one disk is failure, still we can able to access the data. But problem with the mirror is mirror will be broke if you replace, if anything, if you replace a disk, mirror will broke. Why I'm saying broke? It break. BRE. It break the mirror. So like we can use broke, break. It will break the mirror. So that's it. So in a RAID 5 we are using a 3 disk. So it's called also, it is also a single disk failure but with parity. So mirror is without parity, here is a parity. So because of the parity, it regenerates the data. If you replace the disk, data is regenerated into new disk. Okay, if one disk is failure, still we can able to access data like a mirror. And total size of the accessible size is 2 by third of total size of the disk. In RAID 6 we are using 5 disk, and if 2 disk is failure, no problem, we can use with the parity. Total volume size is 2 by 5th of total size. So this is about your RAID 6. There is a different RAIDs also available. By combining RAID 1 RAID 0 become RAID 10, combining RAID 5 and RAID 0 become RAID 50 also. Okay, and this is the storage part 2. So what I'm going to do is